let's take a look at traversing a linked list. Now, a doubly linked list. Now, this code shows the introduction of a doubly linked list class. And I'm trying to do this gently this semester, especially if you barely remember object-oriented programming from before, but this is going to be a very popular implementation where a data structure such as this doubly linked list will be implemented as a class. It's technically called an ADT or an abstract data type. So we will see these classes over and over and over. That's why we're gradually learning about them, about constructors and destructors this week, and dynamic memory from last week that we're reviewing this week, et cetera. You get the idea. So we have got this class with these privates and the publics, and a couple of the public methods are the ones that we will use to traverse the list. And these are both of those. We have two of them. The first is going to traverse the list going forward. And then the second one is going to do exactly the opposite, go backward. So let's take a look at how it's going to do that and what the code is actually doing each step of the way. And here's our setup with a traversal. So the print method traverses this. And here's the code, kind of pseudocode, but this is what is going on line by line here. The first thing we do in line 1 is to create another pointer called current, and let's point it to wherever head is currently pointing. There's exactly that, our current pointer, and it's pointing to the same spot that head is pointing. So that is line 1, what's happening there. Now, line 2 is just a guard. It's going to make sure that we don't do anything else if this list happens to be empty. So line 2 checks to see if the list is empty or not. If it is, head is pointing to the null pointer. And since in line 1, we're telling current also to point to the null pointer, that's going to pick that up in line 2 and return out of the function, out of the print function. Otherwise, we'll keep on going. Now, in line 3, what this is saying is as long as when we advance this thing down the linked list, as long as we continue to point at valid nodes, then that loop's going to continue. So remember that while current, that's the same thing as this statement here, while current is not equal to the null pointer. These two statements are exactly the same thing. All right, and then what we do next is since current currently is valid, well, then we can go and output its data. So whatever data is being stored in that struct, right now it's just an integer, but this week we're going to start looking at storing objects in there. And that's going to be our spot where we access the data or the object. It's right here in this line. But then an important part happens, and we have to then advance the current pointer to the next node. And we do that in line 5 here. We're just saying current is going to now point to wherever current next is. So current is currently pointing to this node, and this node's next pointer is this one right here. So current next is actually pointing to this node. And we want to tell it, all right, advance the current pointer so it's no longer pointing here anymore, but pointing right there. And that's how that current pointer is going to continue to advance and advance and advance, just like in the singly linked list.